Hey, today we're going to look at partial derivatives given contour maps. We'll look at it from a couple of different perspectives. We're just going to look at the partials with respect to x, and then again with respect to y. Just three straightforward examples. Partials. First derivative partials is pretty straightforward given a contour map. All right, so here is our first example. Looking at x squared e to the negative y. The partial of f with respect to x is 2x e to the negative y. I just plugged in some arbitrary point, which we'll look at in a second on the contour map, and we get 3.297. We just want to know, is the partial of f with respect to x and also y in a minute, are they positive and negative? That's all we need to determine given the contour map. So here is our contour graph. So notice that we have these function values written up top here. A half, 1 goes up increments of 0.5. 1.52 and such. And the point we're talking about is point A, which is 0.6065, comma negative 1. And the function value corresponds to 1. And it's pretty straightforward to see as I go in the positive x direction, right? So I'm looking at what's happening to my function values as I go in the positive x direction. I'm going from 1 to 1.5 to 2 to 2.5. Pretty clear that my function values are getting larger, or f is increasing. So the partial of f with respect to x would be positive. So let's look at the average rate of change between a and b, just a different perspective. The average rate of change, the change in my function values is a half, right? Because I'm going from 1 to 1.5, which is 0.5. And then b minus a, the change in the x values is 1363, which gives me 3.66. So that's our approximation. I don't really care what the approximation is. I'm just trying to give you a different perspective on is fx positive or negative. Pretty clear that would be positive. So therefore, another way to look at it is f is increasing. We just kind of talked about that, looking at my function values are going from 1 to 1.5, so therefore fx is positive. I also took the graph, so I took these ordered pairs of all these dots here, I think like the first 5, and plotted them on the xy plane, where the x-axis is our x values, so 0.605, 7428, you can see those here. I started at 429, which is this point over here. And then my y-axis, or my vertical direction, is my z-axis, right? So 0.5, 1, 1.5, and 2.5, those are my function values I get here. And as you can see, it looks like my function is increasing. So therefore, we can say, again, fx is positive. So f is increasing. So fx is positive.